What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this video, you're going to learn about various hardware and software networking tools in addition to various command line interface tools. So let's talk about hardware tools. And the first one we're going to talk about is the crimper. So a crimping tool, this is a device used to conjoin two pieces of metal by deforming one or both of them to hold each other. The result of the tool's work is called a crimp. A crimper attaches a connector to the end of raw twisted pair or coaxial cable. If you are working with twisted pair, you need an RJ45 crimping tool, which often also works with RJ11 telephone cable. After untwisting the wire pairs and aligning them according to the appropriate standard, which is typically a T568B standard, you want to insert them into an RJ45 connector and push the cable and connector assembly into the crimper. Line up the crimper jaw with the recessed area of the connector and then squeeze. Next, we have a cable tester, and this is an electronic device used to verify the electrical connections in a signal cable or other wired assembly. Basic cable testers are continuity testers that verify the existence of a conductive path between ends of the cable and verify the correct wiring of connectors on the cable. More advanced cable testers can measure the signal transmission properties of the cable, such as its resistance, signal attenuation, noise, and interference. Cable testers include a LAN testing unit that could be plugged into a port on the patch panel and a terminator that could be plugged into the other end of the cable into the corresponding RJ45 jack. This tool tests each wire in the cable and makes sure everything is wired properly. Next, we have a punch down tool, and this is a small handheld tool used by network technicians to insert wire into insulation displacement connectors, patch panels, or punch down blocks. A punch down tool punches individual wires down into the 110 IDC clips of an RJ45 jack and the patch panel. The punching down of the wires is the actual termination. The patch panels connect the various ports of the patch panel to a switch and the RJ45 jacks to the computers. Next, we have an OTDR, or an optical time domain reflectometer. So an OTDR, this is a device used to precisely detect faults in an optical fiber link of a communication network. An OTDR simply generates a pulse inside a fiber to be tested for faults or defects. Pulses are returned to the OTDR and their strengths are then measured and calculated as a function of time and plotted as a function of fiber stretch. The strength and return signal tell about the location and intensity of the fault that is present. Next, we have a light meter, and this is a low-cost way to certify optical fiber by measuring fiber optic light continuity, loss, and the actual strength of the optical signal. In fiber optics, when a beam of light which carries a signal goes through the optical fiber, the strength of that light beam will diminish over distance. This means the signal strength becomes weaker. The loss of light power will affect the fiber optic network in a negative way. The loss of light power or attenuation of the optical fiber is caused by two issues: scattering and absorption of the light source. If the degradation is too great, then the performance of the network will be affected, and potential causes of signal loss include the following: tight bends in the cable, dirty or improperly cleaned connectors, too much stress on the cable during installation, poorly installed connectors, improper splicing techniques, and poor cable quality. Then we have the tone generator and probe. A tone generator and probe kit, this is an excellent tool for finding individual phone lines, and it consists of two components. You have the tone device. This connects to one end of the network cable and sends a tone along the length of the cable. And then you have the probing device. This is also known as an inductive amplifier, and it can pick up the tone anywhere along the cable length and at the termination point. Next, we have a Loopback Adapter, and this is also known as a Loopback Plug, and this is a connector used for diagnosing transmission problems. It plugs into an Ethernet RJ45 or serial port and crosses over the transmit line to the receive line so that outgoing signals can be redirected back into the computer for testing to verify whether the network adapter and TCP IP are functioning properly. Multimeter. So a multimeter, also known as a multi-tester, this is an electronic measuring instrument that combines several measurement functions in one unit. A typical multimeter can measure voltage, current, and resistance. Analog multimeters use a microammeter with a moving pointer to display readings. Digital multimeters, which are the most common in use today, they have a numeric display and may also show a graphical bar representing the measured values. Multimeters can be used for testing both coaxial and twisted pair cabling, as well as AC and DC voltages to test computer power supplies and AC adapters. All multimeters have standard red and black test leads. When used for voltage tests, the red lead is attached to the power source to be measured, and the black lead is attached to the ground. Next, we have a spectrum analyzer, and this measures the magnitude of an input signal versus frequency within the full frequency range of the instrument. The primary use is to measure the power of the spectrum of known and unknown signals. The input signal that most common spectrum analyzers measure is electrical. However, spectral compositions of other signals, such as acoustic pressure waves and optical light waves, can be considered through the use of an appropriate transducer. Spectrum analyzers for other types of signals also exist, such as optical spectrum analyzers, which use direct optical techniques, such as a monochromator, to measure measurements. By analyzing the spectra of electrical signals, dominant frequency, power, distortion, harmonics, bandwidth, and other spectral components of a signal can be observed that are not easily detectable in time domain waveforms. These parameters are useful in the characterization of electronic devices, such as wireless transmitters. The display of a spectrum analyzer has frequency on the horizontal axis and the amplitude displayed on the vertical axis. To the casual observer, a spectrum analyzer looks like an oscilloscope, and in fact, some lab instruments can function either as an oscilloscope or a spectrum analyzer. Now let's talk about software tools, and the first one we're going to talk about is called a packet sniffer. And this is a computer program or computer hardware, such as a packet capture appliance, that can intercept and log traffic that passes over a computer network or part of a network. Packet capture, this is the process of intercepting and logging traffic. As data streams flow across the network, the analyzer captures each packet and, if needed, decodes the packet's raw data, showing the values of various fields in the packet, and analyzes its contents according to appropriate specifications. Next, we have a port scanner. So a port scan, this is the process that sends client requests to a range of server port addresses on a host with the goal of finding an active port. This is not a nefarious process in of itself. The majority of uses of a port scan are not attacks, but rather simple probes to determine services available on a remote machine. A port scanner, this is an application designed to probe a server or host for open ports. Such an application may be used by administrators to verify security policies of their networks and by attackers to identify network services running on a host and exploit vulnerabilities. Protocol analyzers. This is a tool that could be hardware or software that is used to capture and analyze signals and data traffic over a communication channel. Protocol analyzers work by capturing data across a communication bus and embedded systems. With the help of protocol analyzers, engineers and developers can design, debug, and test their designs through the entire development life cycle of a hardware product. Quite often, protocol analyzers are used for analyzing network traffic on LANs, PANs, and even wireless networks. With the help of protocol analyzers, data can be monitored and decoded, and the captured data can then be interpreted to generate actionable reports and useful information for network system administrators. Wi-Fi analyzer. So a Wi-Fi analyzer allows for you to analyze both 2.4 gigahertz and 5 gigahertz wireless networks in the area. Wireless networks use specific channels within the wireless spectrum. An overcrowded wireless channel results in decreased bandwidth and or connectivity issues for your network. You can use a Wi-Fi analyzer to see what channels are in use and to identify the best channel to set up on your router. A Wi-Fi analyzer can be a standalone device, a program for a desktop computer, or an app on a smartphone. Then we have a speed tester. So most cable ISPs do not have data caps. To determine the actual upstream or downstream speeds your connection achieves with an ISP, you want to use a speed testing website. Many ISPs provide speed testing web page links on their customer service page. Upstream, also known as uploading, this refers to data, page requests, email, and so on that is being sent from your computer or network to the internet. And downstream, or downloading, this refers to any information being being received from the internet. And then we have various command line tools that you need to be familiar with for this examination. The first one is ping. This sends IP packets to check network connectivity. Then you got traceroute. This is similar to ping, but returns path information to an IP address destination. In Mac and Linux, the command is traceroute, TRACEROUTE. Then you have NS-lookup. This gathers the network's DNS information. You have ipconfig. This displays TCP/IP network information on a computer. In Mac and Linux, the command is ifconfig. Then you have IP tables. This is a Linux command to put rules in place for packet filtering for the Linux kernel firewall. And you got netstat. This displays a list of active TCP connections on a local network. Then you got TCP Dump, and this is a data network packet analyzer computer program that runs under a command line interface. It displays TCP/IP and other packets being transmitted or received over a network to which the computer is attached. Then you have path ping. This is used to combine the functionality of ping and traceroute. It is used to locate spots that have network latency and network loss. You got Nmap. This is used to discover hosts, services, and operating systems detected on computer networks by sending packets and analyzing their responses. You got route. This allows you to make manual entries into network routing tables. It distinguishes between routes to hosts and routes to networks by interpreting the network address of the destination variable, which can be specified either by a symbolic name or numeric address. Then you got ARP. This displays and modifies entries in the address resolution protocol cache. The ARP cache contains one or more tables that are used to store IP addresses and to resolve Ethernet or token ring physical addresses. And then you got dig. This performs DNS lookups and displays the answers that are returned from the query name servers. All right, so that was my quick little class on networking tools. So let's go ahead and get into some of this wonderful check on learning. So the first question is, you are helping a friend with a new wireless router. They are complaining that certain areas of their apartment have much slower internet than others. They live in a dense area with many other apartments in Wi-Fi range. Which tool could help you troubleshoot this issue? Would it be a wireless loopback plug, a port scanner, a spectrum tester, or a Wi-Fi analyzer? So they're complaining about their internet being too slow and they live around a bunch of other people. So what is going to help you figure out what might be going on with this issue? And the correct answer is, this will be a Wi-Fi analyzer. This tool will help you figure out the best channel to set your router to so you can hopefully avoid interference with somebody else's Wi-Fi if you live in an environment like this. Next question. Which of the following tools can verify an Ethernet's cable's wires are in the correct order? Would it be a cable tester, a wattage plug, a loopback plug, or an amplimeter? So which one of these will help you verify that you have wired up your wires in the correct order? And the correct answer is, this will be a cable tester. Next question. Which of the following is a device used to test ports, such as a network port? Would this be a tone generator, a loopback plug, a cable tester, or a leakage tester? So which one of these is going to help you test the functionality of a network port? And the correct answer is, this is going to be a loopback plug. So remember, a loopback plug is a device that you plug into the port to test to see if your transmit and receive signals are doing what they're supposed to do, meaning they're sending data out and receiving data. And if that's the case, then you know that that device is good to go. So in summary, we have talked about various hardware and software networking tools in addition to various command line interface tools. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.